So on example today, we're going to be using technology to find the limits. So here, I want you guys to pretty much go into Desmos and set up your graph. So make sure you guys already open a graph and so forth. So we want to make sure that we are able to graph the function itself. So we can just call it f of x equals, so we have x on top and then divided by the square roots of x plus 1 and then minus 1. So the square root of, bottom, so square root of x plus 1 and then outside of that minus 1. So if you guys do notice here, we have a continuous, it kind of looks like a continuous graph. But as soon as if you do plug in 0 here, you will notice that we do run into a little bit of trouble. So again, let me change a couple of things here. So f of x. So if I do start to approach 0 from both the left and the right side, it does look like I'm approaching the same value here, which in this case happens to be 2. But if I do plug in 0, you guys do notice I get undefined. So that's pretty much here. What you want to do is make sure that you are looking into specifically just this part, right? Where am I going to? Even though there is a gap right there, you see the open circle. As soon as I click on it, it does gives me the undefined. So you do want to be careful. But here again, what you're looking for to see is where is it going? Is it going towards the same value? And in this case, it's going towards positive 2. So I can say here that the limit as x approaches 0 from both the left and the right side happens to be equal to positive 2. So again, let's give me a little sketch of the graph. Kind of looks something like this. Again, 2 happens to be right there. And now let's look at example 9. Find the limit as x approaches 2 of f of x if f of x is equal to x equals 1 when x does not equal 2 and x equals 0. F of x equals 0 when x equals positive 2. So essentially what's happening here is that it's kind of confusing because the computer kind of like type it in together here. But what you guys are looking at, so if you go to Desmos, it is a piecewise, it's kind of like a piecewise function, but it just has a whole. So f of x equals 1. That's it. That's all you got to do. And then the other one would be if it's 1, so it says if it's 2, then therefore my function is now 0. So there would be like a hole specifically right here. All right. In this case, I didn't type it in because it is a piecewise function. And I'll show you guys later on how to like type those in into Desmos and also into the TI Nspire. But there is a hole there. So just pretty much it's a little jump if you guys want to think about it that way. So if you do look at the graph for this one, so we do have kind of like, it's just pretty much a line and it has a hole right there. And that's when this happens. So here I can say that the limits as f of x, the limit of f as x approaches 2 of f of x, in this case happens to be equal to, again, positive 1, right? Because that's pretty much where it's always been at. It just has that jump right there, has that hole. All right, so it would be the closed circle would be down here pretty much. And then let's look at example 10. So example 10, the limit as x approaches 0 of the absolute value of x divided by x. Now, it is an absolute value function, but that does not necessarily mean it's going to look like an absolute value function. So let's type it in. So f of x equals the absolute value. We put in ABS. So ABS of x divided by x. And that should give you guys, put a space in between. Yeah. So it gives us the graph right there, those two lines. And if you guys notice, so it makes the jump. So we're getting closer and closer and closer to 0. And boom, it is undefined. And then over here, it is also undefined. So it's two open circles in between those two, right? So it's not necessarily, you can say, well, it's equal to 1 on top, and then it's equal to -1 at the bottom. That means that it's equal to +1. So here, in this case, I want to make sure that I'm looking towards defining where is it going to, and I can say that the limit as x approaches 0 from the left side is -1, and the limit as x approaches 0 from the right side is +1. So therefore, I would say that the limit does not exist in this case. So again, you want to make sure you guys write down your justification. So the limit as x approaches 0 from the left of f of x, or the function itself, x, absolute value of x divided by x is equal to -1. And the limits as x approaches 0 from the right side of the absolute value of x over x equals +1. So I can say that the limit as x approaches 0 of the absolute value of x over x does not exist. All right. And then we're going to have a look at one more example right here. So example 11, find the limit as x approaches 0 of the sine of 1 over x. So again, go back to Desmos. So sine of 1 over x. Okay. Now here we are trying to see what happens when we get close to 0. And if you guys notice, it's kind of like a little accordion right there in the middle. So what does happen when we get closer and closer and closer to 0? So it doesn't necessarily tell me, like it makes a little jump between those two. Okay, let's see if I get closer. So like if you guys notice, the closer you get, just the line starts getting closer and closer together. So it kind of is nearly next to impossible for me to determine where is this function going to as I get closer and closer to 0. Right, so that's where we're at. And again, if you guys don't believe me, well, in this case, I would say that the limit does not exist, right? So the limit fails to exist here because honestly, I don't know where it's going to. And if you guys want to challenge it, you can keep zooming in, see as far as you guys can go, see what happens.